AX and AY are. Now the next thing I did is I looked at joint G, which is acted on by three members. There are three members connected at the joint G. There are no applied loads to the joint. Two of the forces are collinear, the third is at an angle. It makes no difference what that angle is. When I take the sum of forces in the direction perpendicular to those members, set that equal to 0, there is only one force that has a component in that direction, and therefore that force is always going to have to be 0. It's a zero force member. The same thing is going to hold true over here at joint F. So I can look at this and immediately say those two are going to be zero force members. Furthermore, if I sum forces along the common line of those two members, set the sum of forces equal 0, I find that the force in member AG and the force in member CG, TCG minus TAG plus the force TBG times the cosine of theta has to be 0, but since I already know that TBG is going to be 0, then TCG and TAG have to be equal. So this special joint, three members at an unloaded joint, two members collinear, third at an angle. The third is always a zero force member. The other two have equal magnitude, either both tension or both compression. And the same way on the other side. Next, I took a quick look up here at joint B and said, if BG is a zero force member, now summing forces horizontally is going to tell me that that force has to be 0. Summing forces vertically, this force has to be 0. So in fact, those are also zero force members. Can I throw them away? Well, maybe I could, unless I was going to apply some other loading to the truss. Then they might become important. But more than that, this long member, AGC, is going to be a compressive member, and if I don't protect it somehow, it's going to buckle. When you take a yardstick and push on the ends of it, the middle bows out. So we constructed all of this stuff out here just to help support that joint, help support the center, and keep it from buckling out. So yeah, these are all zero force members, but they do serve a purpose. They hold that in place. When I go over to member D, or joint D, even though DF is a zero force member, I have a load on here, so I am going to have to look at that joint by itself. And when I look at joint D, the forces acting on it are going to be the 2,000 pound force. I'm going to have a tension in CD. This force I already know is equal to 0. And then I'm going to have the force TDE. So by summing forces horizontally, I get TCD plus the component of this zero force member minus, that's negative TCD. This isn't erasing worth a darn here. So minus TCD minus 2,000 equals 0, and TCD is going to be negative 2,000 pounds. Summing forces vertically, the only force is TDE, plus the vertical component of this one, but it's already 0, so that doesn't matter at all. And I get that TDE is going to be equal to 0. So now perhaps, let's see, I did joint D. The next joint that I looked at was A. So if I look at joint A, I have the support reaction AX, which I don't know. The support reaction 4,232.0508 pounds. I'm going to have the force TAB, which I've already determined is 0. And then I've got the tension in TAG, and we were told that that was a 60-degree angle. So I can sum forces horizontally. I get AX plus TAG times the cosine of 60 equals 0. Sum forces vertically, get TAG times the sine of 60 plus 4232.0508 pounds plus TAB, but that's 0. Sum of forces equals 0, so I can solve for TAG. TAG is going to come out to be negative 4,886.7514 pounds. And TAG and TCG are going to be the same because of this special joint here. So this is going to be the same as TCG. And then from the first equation, once I know TAG, I can solve for AX, which is going to come out to be positive 2443.3757 pounds. And I guess next I'll go over to joint E. I could have gone to joint C instead. That would have given me what I'm looking for just as easily, just as nicely. But if I do joint E next, joint E is going to be acted on by the support reaction, 767.9492 pounds. It's going to have the support reaction EX, which I don't know. It's going to have the force TDE, which I know is equal to 0. And it's going to have the force TEF. And again, this is a 60-degree angle in here. So again, I can sum forces horizontally, get minus TEF cosine of 60 minus EX, sum of forces equals 0. Sum forces vertically, 767.9492 plus TEF sine of 60 plus TDE, which I know is 0. Sum of forces equals 0. So TEF is going to come out to be negative 886.7514 pounds. And just like AG and CG were equal, EF and CF are going to be equal. So this is the same as the tension in CF. And then once I know TEF, I can solve for EX. And EX comes out to be positive 443.3757 pounds. So that says I guessed correctly for the directions of AX and EX on the overall equilibrium. And I guess all of the internal members are in compression. I got negative values for all of the internal members. So we can summarize the results. AX, AY, EX, EY, AB, BC, BG, DE, DF are all zero force members. AG equals CG, 4887 pounds compression. I drew it as a tension on my free body diagram. I got a negative value, so it's actually a compression. And EF, well, I guess before I do that, CD, we got a value for CD of negative 2,000. So CD is 2,000 pounds, also compression. And CF, EF are equal. Those are both 887